This is the guts of a Maxlite 12-watt LED downlight retrofit module thing. Just got this because a local discount store had this for $5. Basically got it as a specimen for my collection, because personally I don't really like downlighters aside from in applications where they actually work. But anyways, this is the MCPCB with all the power LEDs on it. There's 25 of them if I counted correctly. One thing that's a bit concerning, just by virtue of the fact that's a point of concern just by virtue of the fact that this is a mains device, is that there's a couple of solder balls floating around. There's one of them there. There's another one stuck right to the side of that LED. The autofocus doesn't puke. See, there's one of them. So yeah, that's not very good, but then again, lead-free solder. Something so wonderful that it's specifically excluded from use in anything where, if that particular device will fail, people will die. You know, medical, military, aerospace, any kind of high-rel stuff. Nuclear power plant control systems in general, etc. But anyways, looks like all these LEDs are wired in series, and they do decent thermal management, at least in the copper on this board, because you can see rather than cut out, have individual tracks, what they do is they cut out individual lands so that there's a whole plane of copper there helping to conduct heat through the fiberglass substrate, just because that's the highest, that's got the highest thermal resistance of any component in the board. And there's also these isolated pads under each LED. Don't know if that's because these might float at some oddball intermediate potential. I have seen some stuff in some power LED data sheets, at least years ago, that the thermal pad actually did float at some oddball intermediate potential between the anode and cathode connections. Then there's these two wires, which are just input feed, obviously they're just constant current drive. Probably about in the neighborhood of about 100 to 150 milliamperes or thereabouts. And that just goes, yeah, more like 150 milliamperes, that just goes to a power supply on the underside of this board. And there's the power supply for this thing. It's potted in this squishy stuff that I've seen in other teardowns of LED lighting driver type stuff. There's the output cap, input one. Just looks like a simple offline switcher. So the output is probably not isolated, which isn't surprising given that all the screw holes on the MCPCB, there's a decent amount of pullback around them, but that's just decent design practice with the PCBs anyway. So it might be isolated, might not be, but focus. There you go. But anyways, there's just a couple of random things, like there's a fusible resistor there. Other resistor, couple film caps, another lytic that's probably the main input. Full suppression cap, transformer, or that's either inductor or transformer. There's again the squishy stuff, so you could dig this out and see what's under it, but I'm not planning on doing that because this is principally a technical specimen. But it's just going to be a simple current limited 80 odd volt switching supply. So nothing extremely interesting there. And there's also just this thing, which is a screw base adapter just to install a lamp holder in the existing fixture, and this disconnect thing, which is just so that you can unplug the adapter from the light, screw that in, and then plug it back in when you install the light, so it makes installation a bit easier. Other than that, nothing too fancy, just a... Oh, and also this casting, which is, I'm guessing, probably Zamak alloy, because it doesn't feel like aluminum. That's just, it's using this whole face as a heatsink, which is actually reasonable design, and these don't tend to run screamingly hot when they do that, but then it's proper design practice, and blah blah blah.